Good morning student. Previous class I discussed about the ionic product of water and also I discussed about pH and I also discussed about some problem related to the pH. Now I am going to discuss about buffer solution. What is the meaning of buffer solution? How many types of buffer solution? What are the importance of buffer solution? Before going to the buffer solution, I want to take an example. Suppose take some water in a beaker. Suppose add few ml of acid. This is your water. Add some ml of acid in this water, then what will happen? An acidic solution is formed. If I will add more and more amount of acid to the fixed amount of water, then what will happen? The acidic strength goes on increases. Similarly, take another beaker. In this beaker, suppose take few ml of water. If I will add a base in this beaker, then what will happen? The basic strength goes on increases. If I will add more and more amount of base to the fixed amount of water, then what will happen? The basic strength goes on increases. And this solution is said to be basic solution. Similarly, take another beaker. In this beaker, suppose few ml of water is present. If I will add some amount of salt, then a solution is formed. This solution may be acidic or may be basic or maybe neutral in nature. That depends upon the salt. According to the salt, the solution may be acidic or may be basic or may be neutral. From this discussion, it is clear that when I will add few amount of salt or few ml of acid or few ml of base in water, then what will happen? Whether an acidic solution or a basic solution or a neutral solution is formed. But remember, buffer solution is a one type of solution whose pH value does not changes appreciably upon the addition of small amount of acid, base and water from outside. Generally, we know that when we add acid or base in water, then what will happen? The basicity or acidity goes on changes. But buffer solution is one type of solution whose pH remain constant appreciably upon the addition of small amount of acid, base and water from outside. So we concluded that a buffer solution may be defined as a solution whose pH value does not change appreciably upon the addition of small amount of acid, base and water from outside. Next, I want to explain about the types of buffer solution. How many types of buffer solution? Generally, there are two types of buffer solution. One is your simple buffer solution. Second is mixed buffer solution. What is the meaning of simple buffer solution? What are the examples of simple buffer solution? Next, I want to discuss about mixed buffer solution. What is a mixed buffer solution? how many types of mixed buffer solution and what are the examples of mixed buffer solution. At first, I want to discuss about the simple buffer solution. A salt of weak acid and base. A salt of weak acid and base in water act as a simple buffer. Again I will repeat, a salt of weak acid and base in water is considered as simple buffer. Suppose, take an example, how can you prepare a simple buffer? Before going to discuss about the simple buffer, at first I want to explain what is a salt of weak acid and base. There are different types of salts are present. Now I want to take a salt of weak acid and base, and that salt is added with water. As a result, a simple buffer solution is formed. Suppose take an weak acid H2CO3. This is an weak acid. Suppose take an weak base Ammonium hydroxide. This is your said to be an weak acid. This is your said to be a weak base. When this acid and this base undergoes reaction, then it gives a salt and also water is formed. That means here I can write the product NH4 twice CO3 plus water. Look at that, this is your salt which is prepared by the help of weak acid and weak base. So the name of the salt is your ammonium carbonate, and it belongs to salt of weak acid and base. Now take this salt and it is dissolved in water. As a result, a solution is prepared, and this type of solution is said to be simple buffer solution. Take another example. Suppose I will take a weak acid, that is your formic acid. This is an example of weak acid. Take a weak base. This is your ammonium hydroxide. This is your a weak base. When this acid and this base undergoes a reaction, then it gives a salt. The salt is HCO NH4. Also water is formed. This is a salt which is prepared by the help of weak acid and weak base. So it belongs to salt of weak acid and weak base. When I will take the aqueous solution of this salt, then a simple buffer solution is formed. Similarly, when I will take the aqueous solution of this salt, then a simple buffer solution is formed. So the examples of simple buffer solution are aqueous solution of NH4 twice CO3. Another example is an aqueous solution of HCO NH4. Next example is aqueous solution of NH4 CN. These are the examples of simple buffer solution. Remember, if I will add few amount of acid or base or water from the outside, then what will happen? The pH of such type of solution does not changes appreciably. That's why this type of solution is said to be buffer solution. Buffer solution means the pH value does not changes appreciably upon the addition of small amount of acid, base and water. But remember, if I will add more and more amount of acid, bases or water from the outside, the pH value must be changed. So it is only applicable for small amount of acid, base or water from the outside. Next I want to explain about the mixed buffer. Mixed buffer is of two types. One is your acidic buffer, another is your basic buffer. At first I want to discuss about acidic buffer. What is acidic buffer? What are the examples of acidic buffer? Acidic buffer solution contain equimolar quantity of a weak acid and it's a salt with a strong base. Suppose take a weak acid CH3COH. If I will think about the salt with strong base, that means it's a salt with strong base. Then take an example when acetic acid subjected to reaction with a strong base. Suppose I will take sodium hydroxide as a strong base. Then what will happen? This acid and this strong base undergoes a reaction and it gives a salt and also water. This is your salt and this salt is prepared by a weak acid and a strong base. So this salt belongs to salt of weak acid and strong base. Suppose I want to prepare the acidic buffer solution. Suppose take a beaker, take the acetic acid in this beaker, then add the sodium acetate. This is your said to be sodium acetate. Take this sodium acetate in this beaker and make a solution. This solution is said to be acidic buffer solution. But remember, here equimolar quantity of weak acid and its a salt with a strong base are taken. That means equimolar quantity of acetic acid and sodium acetate able to form a acidic buffer solution. Similarly, take another example. This is your formic acid and it's a salt with a strong base. Suppose I want to take HCOK because this salt is prepared by the help of strong base KOH and formic acid. So this is a salt of weak acid and strong base. So remember, an equimolar quantity of formic acid and potassium formate also able to form a acidic buffer solution. Next, I want to explain about the basic buffer. Basic buffer contain equimolar quantities of a weak base and it's a salt with a strong acid. How can you me explain with an example. Suppose take a weak base, ammonium hydroxide. It's a salt with a strong acid means when ammonium hydroxide react with a strong acid. Suppose I want to take a strong acid HCl, then what will happen? Ammonium chloride and water are formed. This is an example of salt, and this salt belongs to salt of weak base and strong acid. Now take equimolar quantities of ammonium hydroxide and ammonium chloride in a beaker, then a solution is formed, and this solution is said to be a basic buffer solution. You can take any weak base and it's a salt with strong acid, and you can able to form basic buffer solution. But remember, both species must be taken in equimolar quantities. Equimolar quantity means, suppose I will take 1 mole of ammonium hydroxide, then it is bound to take 1 mole of ammonium chloride. Suppose I will take 10 mole of ammonium hydroxide, then it is bound to take 10 mole of ammonium chloride for the preparation of basic buffer solution. Like this, it is also bound to take equimolar quantities of weak acid and its a salt with strong base for the preparation of acidic buffer solution. Equimolar quantities means same molar quantities. There are many examples of acidic buffer solution and also many examples of basic buffer solution. Next, I want to explain about the action of acidic buffer solution. That means I want to explain about the role of acidic buffer solution. When I will add few amount of acid or base or water from the outside, why the pH of the acidic buffer solution do not changes. Take an example of an acidic buffer solution. Equimolar quantities of CH3COH and CH3CONA. Remember an important point. Always the strong acid, strong base and strong salt undergoes complete dissociation and gives completely ions. In case of strong acid or base or salt, the unionized part is 0. That means completely it undergoes dissociation and gives ions. But if you think about the weak acid, weak base or salt of weak acid and weak base, then in this type of case, this species does not undergoes complete dissociation. Some unionized part remain in the solution. Suppose I will think about the acidic acid, it is a weak acid. That means some part of this acid undergoes dissociation and few amount of this type of weak acid remain as unionized. But if you think about this salt, then this salt undergoes completely dissociation and gives the ions. In this type of salt, the unionized part generally remain 0. When CH3CONA undergoes dissociation, then it gives CH3CO minus plus Na plus 100% 100% of this type of salt undergoes complete dissociation and gives 100% CH3CO minus ion and 100% Na plus ion. Suppose if I will think about the acetic acid, when acetic acid undergoes dissociation, then it gives CH3CO minus plus H plus. Such type of reactions are generally reversible reaction, and this type of reactions are generally irreversible reaction. Suppose I will take these two species in a beaker, then what will happen? In this beaker, CH3CO minus ions, H plus, Na plus and unionized acetic acid are present. The species which are present in this beaker are CH3CO minus, H plus, Na plus and unionized CH3COH. So I can think that in this type of buffer solution, the concentration of Na plus, H plus, CH3CO minus and unionized acetic acid molecule is large. Now I want to explain why the pH of this type of buffer solution remain constant after addition of acid, base or water from outside. Let me explain about the mechanism related to the acidic buffer solution. Suppose I want to add few drop of acid from outside, then what will happen? As a result, the pH of this type of buffer solution remain constant. Remember, when few drop of acid, that means H plus, are added to this buffer solution, then the H plus ion of acid immediately combine with the CH3CO minus ion to form undissociated acetic acid. That means when I will add few drop of acid, a reaction occur. This reaction is your CH3CO minus plus H plus gives the CH3COH. This is your weak acid. As a result, it is very difficult to break this weak acid again. Once the weak acid is formed, then it is very difficult to break this weak acid to form the ions. Remember an important point, a species is said to be acid or base when it gives the ions. That means when the acid undergoes dissociation and then it gives the H plus ion, then that type of species is said to be acid and it shows its acidic character. Similarly, when a species undergoes dissociation and it gives OH minus ion, then we generally think that the base shows its basic character. Otherwise, we cannot think about the acidic or basic character. If I will take acetic acid in this beaker, if the acetic acid do not undergo dissociation and do not give the H plus ion, that means we do not think about the acidic character of this acetic acid. When this acetic acid undergoes dissociation and it gives a H plus ion, that means we generally think about the acidic character of this acetic acid. Otherwise, we cannot think about the acidic character of this acetic acid. That means when an acid undergoes dissociation and it gives the H plus ion, then we generally think about that this acid shows the acidic character. Similarly, if a base undergoes dissociation and it gives OH minus ion, then we generally think about that the base shows the basic character. Otherwise, we cannot think about the basic character of the base. Before adding the few drop of acid, here the ions are present, that is your CH3CO minus ion, H plus ion and Na plus ion present in this beaker. When I will add the acid from outside, then what will happen? This reaction will happen in this beaker. As a result, the added H plus ion will not affect the pH value. The pH of this buffer solution is accordingly the H plus ion which is already present before the addition of the few drop of acid. If I will add more and more amount of acid, that means H plus ion from the outside, then the added H plus ion will combine with the CH3CO minus ion and able to form the acetic acid, and this acetic acid remain in unionized condition. If this acetic acid remain unionized condition, then it will do not affect the pH value of the buffer solution. But remember, if this acetic acid undergoes dissociation, then it gives an impact to the pH value of the buffer solution. Remember, if I will add more and more amount of acid, that is your H plus ion from the outside, then the pH value of this buffer solution undergoes changes. The pH remain constant up to a certain limit of addition of acid from the outside. If I will add few drop of acid, then such type of reaction will happen in this type of buffer solution. The pH value do not depends upon the added H plus ion from outside. It only depends upon the H plus ion which is already present in the buffer solution. If I will add few drop of base from outside, then what will happen? This type of reaction will happen. The reaction is your CH3COH plus OH minus gives a CH3CO minus plus water. Look at that. Here there is no formation of H plus ion by the addition of base from outside. As a result, the pH remain constant. If the added base, that means OH minus ion, will not react with the undissociated C3COH, then it will affect the pH value. But when we add, then such type of reaction will happen. As a result, the pH will not affect by the addition of few drop of base. Remember, in this buffer solution, the H plus ion only affect the pH of the solution, or you can also think about that the OH minus ion also affect the pH value of the buffer solution. Accordingly, we think about the pH value of the buffer solution basing upon the pOH value. If the added OH minus ion will present in the buffer solution without the reaction, then it can affect the pH value of the buffer solution. But here it is seen that the added OH minus ion suddenly react with the unionized acetic acid, and suddenly CH3CO minus ion and water is formed. These type of species do not affect the pH of the buffer solution. So after addition of few drop of base, this type of reaction takes place. Due to this reaction, the pH of the buffer solution will not change. If I will add few drops of water from the outside, then what will happen? We know that water have one H plus ion and one OH minus ion. The added H plus ion combine with the acetate ion to form the acetic acid. Acetic acid is a weak acid, it does not undergo dissociation easily. On the other hand, the OH minus ion combine with the undissociated acetic acid to form the acetate ion and water. If I will add the acid from the outside, only this reaction will happen. If I will add few drop of base from the outside, only this reaction will happen. But remember, if I will add few drop of water, then simultaneously both these two reactions will happen. As a result, the pH of the buffer solution remain constant. This is all about the action of acidic buffer solution. Next, I want to explain about the action of basic buffer solution. Suppose take a basic buffer solution, equimolar mixture of ammonium hydroxide and ammonium chloride. When I will take equimolar mixture of ammonium hydroxide and ammonium chloride in a beaker, then what will happen? Ammonium chloride is a salt of strong acid and weak base. So ammonium chloride completely undergoes dissociation, gives the NH4 plus Cl minus ion. But on the other hand, ammonium hydroxide is a weak base. It do not undergoes completely dissociation to give NH4 plus ion and OH minus ion. Some amount of ammonium hydroxide is present in undissociated condition. So in this beaker, the concentration of NH4 plus and concentration of Cl minus ion and concentration of OH minus ion and concentration of undissociated ammonium hydroxide is large. When I will add a few drop of acid from the outside, then what will happen? The added H plus ion suddenly react with the unionized ammonium hydroxide to form the NH4 plus ion and water. I can write the reaction like this: NH4OH plus H plus gives a NH4 plus water. Look at that. Here the added H plus ion suddenly react with the undissociated ammonium hydroxide and to form NH4 plus and water. That's why the added H plus ion do not affect the pH of this type of buffer solution. But remember, if the added H plus ion will not react with the NH4OH, then it can affect the pH value of the buffer solution. But here, the H plus ion suddenly react with the NH4OH and forms the NH4 plus and water. So the added H plus ion do not affect the pH value of this buffer solution. Similarly, when I will add a few drop of base from the outside, then the added OH minus ion suddenly react with the NH4 plus ion which is already present in the buffer solution. As a result, ammonium hydroxide is formed. This ammonium hydroxide will not affect the pH value of this buffer solution. Similarly, if I will add few amount of water from the outside, we know that water gives a 1 H plus ion and 1 OH minus ion. Due to this H plus ion, this type of reaction occur. Due to this OH minus ion, this type of reaction occur. That means if I will add the water molecule from the outside, simultaneously both these two type of reaction will occur. Again, I will repeat, if I will add the H plus ion, then this type of reaction will possible. If I will add the base from outside, then this type of reaction will happen. Similarly, if I will add the water molecule from the outside, then both these two type of reaction will happen. That's why the pH of basic buffer solution will not affect by the addition of acid or base or water from the outside. This is the action of basic buffer solution. Next, I want to explain about the application of buffer solution. What are the application of buffer solution? First application, buffer solution is used for the qualitative analysis of mixture. Second application, buffer solution is used also for the quantitative analysis of estimation. Next application is buffer solution is used in the industrial process such as manufacture of papers, dyes, inks, drugs, paints, etc. Next application is buffer solution is completely related to the digestion of food. Our blood acts as a good buffer solution. Next use is preservation of foods and fruits. Next application is agriculture and dairy production and preservation. These are the some application of buffer solution. Next, I want to explain about the buffer capacity. What is the meaning of buffer capacity? It is defined as the amount of the acid or base which, when added to 1 liter of the given buffer solution, changes its pH by unit. Again, I will repeat. It is defined as the amount of the acid or base which, when added to 1 liter of the given buffer solution, changes its pH by unit. Mathematically I can write buffer capacity equal to number of moles of acid or alkali added per liter divided by change in pH. This is the formula for the calculation of buffer capacity. Buffer capacity equal to number of mole of acid or alkali added per liter divided by change in pH. Let me do a problem. The pH of a buffer solution is 4.745 when 0.01 mole of sodium hydroxide is added, then what will happen? The pH changes from 4.745 to 4.832. Again, I will repeat. The pH of a buffer solution is 4.745 when 0.01 mole of sodium hydroxide is added to 1 liter. Then the pH value changes to 4.832. Then find the buffer capacity. We know that buffer capacity equal to number of mole of acid or alkali added per liter divided by change in pH. So here I can write 0.01 mole because in this question the added alkali is 0.01 mole. Here I can write the change in pH means here I can write 4.832 minus 4.745. After calculation it is seen that the buffer capacity of this buffer solution is 0.115. In our question find out the buffer capacity. The buffer capacity of the buffer solution is 0.115. This is all about for this class. Thank you. Have a nice day.